Okay, so I hope you guys did well on the 10B and 12B. So we'll just do this question together. So the instruction on the 350 gram of bag of coffee beans say that proper brewing of a large mug of like pour over coffee requires 20 gram of coffee beans. Okay, and we want to find the largest number of properly brewed large mugs of coffee that can be made from the coffee beans in that bag. So like it's just kind of straightforward, but it's a bit wordy looking. So we just need to divide 350 by 20. So that will be like 17.5, but we want to get the exact like the whole number of things. So we can just do at most 17 of these. You can just take the basically floor of this, which will give us 17. Okay, so number 2, the J wrote down the ones digit of each of the first 20, 25 positive integers, and we want to find the sum of the numbers that was written. Okay, so like we want to find the pattern. So let's write the maybe a bit more. So we get 1 as 1 squared, 2 squared is like 4, and 3 squared is 9, 4 squared is 16. And then 5 squared is 25, 6 squared is 6, 36. And then 49 is like that, 64 will be 4, and then 81 is 1, 100 is 0, 121, like 11 squared is 1, 12 squared is like 12 times 12 is 144. So like after this, we do get the pattern because when you multiply the two-digit numbers, let's say 12, you multiply 12 by 12, so you multiply 2 by 2, which is, last digit to get the last digit. So only digit that's contributed. So which is why when you got 2 times 2 and 12 times 12, you actually end up getting the same thing, which means we are going to have these numbers again for the next like 10 numbers. Okay, then you just have the patterns of the 10 numbers in that case. So like 1 squared all the way to the 10 square. So that means I just need to know how many of these group of 10s do we have in the 2025. So I can just divide this 2020 and then like 5. So in that case, like you have 202 times 10 plus 5. We need that you have group of these 10 numbers 202 times, and then there will be 5 more. So like when you add these, we have these two 10, and then these two is 10, and then that's 20, 25, 31, 40, 44, 45. So which means the sum of these is actually 45. Okay, so which means we are going to have that 45, 202 times. So I can write 202 times 45, and then we're going to get 5 more numbers, starting from the 1, 2, 9, 1, 4, 9, 6, and 5. When you combine these, that's going to be 5, like 10, 20, 25. So that is just going to be sum of the ones digit. Like I can multiply 200 by 45, which is going to be 9,000. And then you got 2 times 45, 90 plus 1, like 25, which is 115. So if you combine this, you just get choice C. Okay, so that wasn't too bad compared to the 10A problem. I guess number 5. Okay, number 3. So the Pascal-like triangle has 10 as the top row and 10 followed by 1 as the second column. Okay, and in each subsequent row, the first number is 10 and the last number is 5, the 1. As in the standard Pascal triangle, each of the number in the row is the sum of the two numbers directly above it. Okay, but only thing is just the starting numbers are different, and then the first number is 10 instead of 1, and the last number is still 1. Okay, and we want to find the sum of the digit of the sum of the numbers in the 11th row. Okay, so like let's start with adding first. Like this is 10, and that looks like 11, and then you got 22, and then you got 10, 31, like 31, 43. That is 44. Okay, so it looks like after the first one, we just multiply by 2. But since like this is the number 3, so I will say this might be actually the case. So without really thinking too much, because it shouldn't be too challenging. So let's do one more row to see if that's really the case. And then I'm going to have 10. And then some of these will be 31. And then you got 33, 13, and 1. So you got 41, 74. And then I got 77 plus 1, 88. Okay, so like, yeah, we did expect double, which is actually double. So at this point, you can say like, we start with the second row, 11. And then to get the third row, we multiply by 2. So, and then to get the 11th row, to get the third row, you multiply by 2 the first time, right? So then you start with 11. Actually, let me write this right here. You start with 11, and then you multiply by 2 the first time to get the third one. But if you are looking for the 11, so you're going to multiply this by 9 times. And if you multiply this by, so 512, so you get the answer like 512, 512. So you got 2, 3, 6, and 5, right? So then if you do add those digits, so that's 11, that's 14, plus 2 is 16. So that is choice D. So like, but if you kind of didn't really apply the doubling part, so maybe we can make this a bit general to actually show that's the case. One thing we can do, like we can just randomly choose a row n, right? So let me say we have a row n. So the numbers in the row n should be like 10. And I'm going to say like this is A1 and then A2. And then you do get like A3 all the way A of n minus 1 and then 1. Like these are the numbers in the row n. Okay, so then if I want to find the row, like next row, n plus 1. So, we start with this 10 on the left end, that's for sure. And then we do have add these two numbers, which is going to be 10 plus A2. I think this is the idea that we use in the number 19 and 10A as well. And then there was also another question like this, a lot of math counts problems I've seen before, but that is just the same idea. And then you add these two. So you got A2 plus A3 and then you got a3 plus a4, and then you just continue doing this. At the end, so you do have like this plus this, right? So the n minus 1 plus 1, comma 1. So what does that tell us? Like if I'm going to rewrite the row n plus 1 in a different way, so that's basically some of these numbers. I'm going to write the 10 plus like this one. Okay, and then now I'm going to write the 10 and a2, right? So that should be 10 and a2. Okay, and then I'm going to write the a2 plus a3. And then that will give you like continue the same pattern. And the last, like I can kind of write the last one as the a of n minus 1 plus 1. So the last two. What I did just, these are not the numbers that I have in the row n plus 1. I just add those, which is basically my sum of the numbers in the row n plus 1. But how this is going to be useful, right? So like now we do have like 10 plus a2, which is like the, when you remember this one, this is like 10 plus a2 right here. When you combine these, and then a2 plus a3. And if you just rewrite these a bit differently, what I mean by that, like when you combine this, I can just say 10 plus a2 and then a3 all the way to the a of an. So let me write it like so you can see like 10 plus a2, and then it will continue all the way to the a of n minus 1, and then plus. So I took one a2 right here. I'm going to pull this and the other one. So I'll just have a2 plus a3 all the way to the a of n minus 1. And then we have 1 at the end. So like, what does that tell us? Like, this is basically, you know, when you start with the 10, a2, which looks like this, a3 all the way to the a of n minus 1. So these guys, but there is also 1 right here. So when you combine that with this one, maybe I should add right here. So this is going to be equal to just the row n, which is like s of n minus 1, or s of n, I'll say, and minus 1, because I'm missing this number 1. And then the same idea when you have this guy right here. Okay, this is basically s of n minus 10, because we are missing the term n, like 10 right here. So what does that tell us when you combine these two? So it looks like 2 times Sn minus 11. Okay, so then this is 2 times Sn minus 11. But you know, we already have the 10 and 1, like which was well, like which was this guy, the 11. When you add that 11 to here, so that's actually become just 2 times SON, which means row n plus 1 is going to be twice of the previous one. So I hope that makes sense. If not, that's fine. Fine, you can maybe just take this to the first approach anyway. Okay, so let's do the number 4, because we spent too much on this one. So the value of the 2-digit number AB in base 7 equals the value of the 2-digit base BA in base 9. Okay, what is A plus B? So like AB is given in base 7, and that's equal to BA in base 9. Okay, that's kind of straightforward. So let's convert it to base 10. So 0 power first power, so you got 7 times A plus B. And that's going to be 0 and 1. So you got 9 B plus A. And that will give us 6A will be 8B divided by 2. So you got 3A equals 4B. So that means this might be 4 and this might be 3. Since we are in base like 7, so it has to be lower than 7. So if I take 4 and 3, that does work. But if I double these numbers to get the same equation, but that will be 8, but 8 doesn't work. So that's only one actually works is 3 and 4. So that is the sum. Okay, that was slightly easier. And the number 5, in a triangle, AB is given, AC is given, B is 130 degrees, and then O is the center of the circle containing the point ABC, which means a circle. Okay, and we want to find the angle CAO. Okay, let's try a circle. And then there's like 130 degrees, so maybe it should be a bit obtuse. I will say it might be like that. So I don't really know, but I just draw some random looking obtuse angle triangle. So this is going to be my obtuse angle, and then that is B. And then since AB is smaller than AC, I'll say this is A and this is C. Okay. And B is 130 degrees, O is the center. So like I'm going to say, let's say center is right here. And what we are asked to get the angle CAO. So CAO. So that is the angle right here. So like when you see this 130, immediately arc AC will be double of that, which is inscribed angle will be subtended by 260. So like we are looking for maybe this one, I can extend this so I can get diameter. So when you do this, that will be 180 degrees for this part. When you subtract 180 from this one, so you should get like 80 for this arc. So this is the let's say this is K. CK is the arc subtended by this angle. So which is like half of this 80 will be our inscribed angle, so which is choice C. Okay, so that was also, I guess, easier. So the number 6, the line y equals 1/3 x plus 1 divides the square in region by defined by the x in between 0 to 2, y is also into upper region and lower region. then the line x equals a divides lower region into two equal region area, then a can be written as this expression, and we want to find the s plus t. Okay, so it is like worthy. So let's try a figure to see what's going on. There is a like square. So let's say this is my square, and I'm gonna place this into xy plane. So if I do that, so it should be like, okay, so let's say that is my plane. Okay, so that's gonna be 2, 0, and then this is 0, 2, and that is my origin. And the line y equals 1/3 x. So y-intercept is 1, so it has to go through right in the middle. And the slope is like 1/3, so you go 1 unit up and then 3 units right. So which means you should go like all the way to the 3. So it looks like my graph should look like passing through these 2 points. So I can draw something like this. Okay, so I can even connect these. Okay, so that's not really, but it's fine. Okay, and what else do we know? 1/3 x plus 1, so this is like 1, so that's 1 unit, that's 1 unit. And that's going to be 3, 2 as well. And the upper and lower region, this is the upper region, this is the lower region, and then the x equals a divides the lower region into equal areas. Okay, so it looks like our x equals a has to be look like something like this. And then x equals a, and then this region is the same as this region. Okay, so then maybe I can find the coordinates, because I kind of need to know that this is a trapezoid, this is a trapezoid, and then this is like a unit, and that means this is going to be 2 minus a unit. And I can just find maybe this intersection, because I like to know the y-intercept of this, so I can get this distance. And then x value is a, and then this goes through this line. So if I plug a into x, so you got 1/3 a plus 1. So which means this point y value, which is this side of the trapezoid, is actually 1/3 a plus 1. So then maybe I can find the area of this region as the half of the area of this region. But what is the area of this region? So like I know this is 1, but I don't know this intersection. Maybe I can find this as well. Another thing I know, like this is 1, and this is 1. If you extend this, so since this is midpoint, so this is similar to this one. So you can see whatever this distance, which is 3 units, has to be here as well. That is also 3. Okay, so then, you know, this is 1 unit, and then this is 2 plus 3, which is 5. So which means this is 1 to 5 ratio, because there is a similar triangle as well. And then we know this is like 1 to 5. So if I call this is 1x, this is 5x, 6x will be 2, x will be 6x will be 2, x is 1/3. So meaning that this is 1/3, and then this is 5/3. Okay, that is so fine. And then now we can find the area of the entire region, the trapezoid, and then we take the half of that. So let's do that. So the 1 plus 5/3 over 2, that's the sum of the parallel sides, times height, which is 2. That's the area of the entire region. But I'm going to take the half of this to get the one of these. So that should be like cancel these. So you got 8/3 and 4/3. Okay, so that means a, I'm going to call this is a, is 4/3. So then maybe you can write the equation now for this region, because that is, you know, this side plus this side. So you got 1 plus a/3 plus 1. That's the sum of the parallel side, divided by 2, multiplied by a. So you got 4/3. Okay, so then I can just solve this equation, I guess. So that will give us like the 2 plus a/3. So, and then if I multiply by 3, so you got 6 plus a/3 divided by 2. That will give us 6. And then times a equals 4/3. So then I can cancel that. So that should be a squared plus 6a equals a. So I'm going to subtract 8 from both sides. And it looks like it is a plus. Actually, no, that's not really nice answer, because we expect to be something like this. I can't use the quadratic formula, but I'm going to complete square. So that should be like a plus 3 squared. And then that will be 8 if you move on the other side, but you add 3 to the left side. So you add 3 squared, which is 9. So that means the a is going to be -3 plus or minus √17. And then negative version doesn't work because it has to be positive. So that should be -3 plus √17. But we are looking for the sum of the s and t anyway. So that should be like 17 plus 3, which is 20. Okay, so this was actually a bit challenging for number 6. So it was a bit longer anyway. Number 7. The Francis stands 15 meters directly south of a lock gate in a fence that runs east-west. Okay. Immediately behind the fence is a box of chocolate located X meters east of the locked gate. Okay, it's getting complicated. So let's start with the lock gate. I'm going to call, so let's say this is the lock gate. And then the guy stands 15 meters south of this. So maybe I should do a visual like this. Okay, and this is 15. And then, okay, and then it goes east and west. Okay, immediately behind the fence is a box of chocolate that is X located X meter east of the lock gate. So which means you're gonna get something. Let's say this is X, and then there's a chocolate right here. Okay, the box of the chocolate. And on lock gate, it lies 9 meters east of the box. So this was the box. And then we have 9 meters east of this. Okay, that's the unlock gate. And now the unlock gate is the 8 meters west of the lock gate. So this was the lock gate, and then we are gonna do now west of this. That's gonna be 9 meters right here. Okay, and then friends can reach the box, which is the box right here, by walking towards the unlock gate, passing through it, and walking towards the box. It happens that total distance that Francis would travel be the same either way. Okay, so that basically like it's telling us you start go from here and come back this way, or you go this way, come back this way, and then either distance will be same. So let's go ahead and do that. The one thing is 9, 15, and then this is gonna be actually no, was it 8 meters west? Right? Okay, so this is 8, so that should be 17. So this distance will be 17 plus a plus x, which is kind of easier. But the other one is kind of not easier because of the hypotenuse not know, but I can use that hypotenuse by using Pythagoras. So you got 15 squared plus x plus 9 square, and then that will be square rooted to get this hypotenuse, and then plus 9. So to cancel this 9, because that's not easier to deal with the radical, so I subtract 9 from both sides. So you got 16 plus x. So 16 plus x equals the 225 plus, when you expand those, you got x squared plus 18x plus 81. And that is on the radical, right? Okay, so if I square both sides, now you got 256 plus 32x plus x squared. And then you got x squared plus 18x plus 225 plus 81. Cancel these. And then you subtract 18 from both sides. So you got 14x. And you got 225 and then 256. Like if you subtract 225 from both sides, this is like 25 to 50 is like 25 plus 6, like you got 31. Subtract 31 from both sides. So you got 50. And then x will be look like 25 over 7. And that is actually what we are looking for. So from the choices, 25 over 7, that's 21 plus 4, which looks like the choice C. Okay, so that will be 24. I think that's choice C. Okay, that's number 7. Let's see the number 8. Amy says to Max, I ordered 36 Math Club sweatshirts today. And Max asks, how much did each t-shirt, like each shirt cost? Amy responds, I'll give you a hint. The total cost was ABB, comma, BA, and BR digits. A is not 0. After a pause, Max says, that was a good price. It looks like Max is smart. What is A plus B? So like, there's not much given, but this is in dollars. So like, imagine this like, if you multiply this by 100, so I'll say that like T. So you will get like A, B, 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 A, I will say cents, right? So then when you multiply this by 100, you got this much cents. So what does that tell us? That means this number is actually divisible by 36, otherwise it wouldn't be a good price, right? So then that means this number is divisible by 9 and 4. To divisible by 4, the last 2 digit, BA, should be divisible by 4. So meaning that A has to be even, and then B is going to be something else. And also to get the divisible by 9, so it's the sum of the digits. So we have 1, 2A plus 3B has to be divisible by 9. So I'm going to say this is congruent to mod 9. And then the BA can be written like 10B plus A. This has to be divisible by 4. So I can write it this way. Okay. Then I can just kind of go through like some, I will say, cases. So first thing I will say, since this is even, that A is even for sure. So we don't have many options. So like A could be like 2, 4, 6, and 8, because we are told A is not 0. And probably one of them will be the only one working on, because there's no other option. So I'll say X like A is 1. If I choose like A is 2, actually, then you will get this will satisfy for sure, right? And if A is 2, you get 4 plus 3B is congruent to 0 mod 9. So imagine like this is 4, that's even number. So you get another even to get the divisible by 9, because it has to be like actually you can get odd numbers as well. But anyway, so let's try with some number. Like if this is like 5, you get 9, but there's no way to get 5. Then to get 18, so you should get this is 14, but that doesn't work. So if you get 27, so you should get this is 23, no way. And then 36 will be 32, right? So that will be no divisible by 3. And then 45 is like 41, no good. So which means since the B is the digit, like max actually B is like 9, that's 27 plus 40, that's 30, like 1. So that means no solution from here for the case 2, right? If A is 2. And then if A is like 4, then you just get the 2 times 4 is like A plus 3B is congruent to 0 and mod 9. Okay, so then like the max B is like 9, so 9, 3 is 27. 27 plus 8 is the max sum you can get, which is like 35, right? So in this case, like to get this, you can choose like maybe not to get 9 to be multiple of 9. So this has to be 1, but that doesn't work. To get 18, so you got this is 10, but it is not multiple of 3. And then 27, so you got 19, that doesn't work. So no solution from here either. And then if A is 6, so you got 6 times 2 is like 12 plus 3B is going to be 0 mod 9. Okay, and so now we can just say, like, to get 18, I should get, this has to be 6, which looks like this is 2. Okay, so let me see if that will be available. So now, like, if this is 2, that does work for this case. Let's keep this in mind. And then what else gonna work? So if I want to have like 18, it does work. Like if I want to get 27, so you got 15, so it looks like 5 is also working because it's just 3 more. And okay, but one of them shouldn't be working. So another thing we remember was this has to be divisible by 4 as well. So if like B is like 2, you got 2 times 10, which is 20, and then A is 6, 26 doesn't work. So that means this is actually removed. And then 5 for B, so you get 50, and then 6, that's actually divisible by 4. It does work. So that is 5D1 working. If you try for A, it doesn't work either. You can test that as well. So the number should be like, our A is like 6, B is like 5, and then you got 5.5, and then 6. So this is the number we should get, but we are looking for the sum of those A and B, so that is 11. So I hope that makes sense. If you want to divide this by 36, you will see actually a number that is divisible by, and then you will get something in cents, which is okay, but that is going to be the answer. Yep, that was number 8. Okay, here's number 9. So how many ordered triples of integers x, y, z satisfy the given system of inequalities? Okay, this is kind of interesting because we have 4 inequalities in the problem, and then they look like symmetric. So let's clear the negative because negative doesn't really look fun. So I'm going to take the first one and multiply by negative. So that should give us x plus y plus z. That will switch the direction, so you get larger than 2. Okay, that's one thing. And if I want to do the maybe find the x, y, z, maybe along from the other one, because each one of these inequalities has one negative. So let's pull the x itself. If I take the x on the other side, so you got x plus 2, but I'll take the 2 out of the way. So that looks like the x is larger than or equal to y plus z and minus 2. Okay, and then the same thing with the next one. So you get y is larger than or equal to x plus z and minus 2. And the last one should be like the z is larger than x plus y minus 2. I'm going to label these. This is like 1, 2, 3, and 4. So because that might be looking a bit confusing. Okay, so what I'm going to try now, since we know the x, y, z is like on these 3 inequalities, is on one side, and then we have like one of the x, y, z on the other side as well, which looks like this metric. So like if I want to maybe take the, let's say 2 and 3 and combine it. So let's do that. So if I add 2 and 3, so you'll get larger than, you got like y, z, and x. So you got x plus, actually write the given order. So you got the y plus z, and then you got x plus z. And then -2 and -2 will be 4. So cancel one of the x and y. So this will be canceling each other. So with that, so you got 2z is minus 4 is larger than 0. So the 2z is less than or equal to 4. So the z is actually less than or equal to 2. Okay, so this is something. Well, using the same logic, because the 3, 2, 3, and 4 are symmetric, so we can just actually get the x is also less than or equal to 2. If I do the same thing with the, let's say 1 and 3, I mean 2 and 4, and 3 and 4, so you can see y is also less than or equal to 2. So this is the power of the symmetry. But now what, right? So we have these, but at the same time, we know that the x, y, z could be negative as well. So that's kind of the bad part of the problem. So if they were all like zeros or positive, so that would be nicer. So which is why, it says z is less than or equal to 2. So I'm going to just do some sort of substitution. Let's say I'm going to let's say a is equal to 2 minus x, and then b is 2 minus y, and then c is like 2 minus z. Why do I do that? Because when you take, this, like the x is at most 2. When you subtract 2 from 2, you got 0. If you should subtract 1 from 2, you get like 1. So if you subtract some negatives from 2, you get positive. So which means a, b, c are all non-negative numbers, which is the reason I just did that. Okay, so then what we can do now, the first equation, like we had, this guy, x is larger than or equal to y plus c minus 2. Maybe I can take that equation. So the x is larger than or equal to y plus z minus 2. And then I replace these guys. So, the x is, I will say, if I pull the x along, so you'll get 2 minus a. So you got 2 minus a. is larger than, and then y would be 2 minus b, and then z would be 2 minus c, and then minus 2. Okay, so then the 2's will cancel, these will cancel. So you got negative a is larger than or equal to negative b and minus like negative c. So if you multiply everything by negative, so you got a is actually smaller than or equal to b plus c. And again, this is not the really the special, because of the 2, 3, and 4 are just symmetric. We can do the same thing as we just did with its equation inequality 2 to get this one. We can do the same thing with 3 and 4, and then you will see that will be b is lesser than or equal to a plus c, and then c is lesser than or equal to a plus b as well. So those are fine, but still we don't really have much progress. So what I'm going to do, if I want to take the a is less than or equal to b plus c, which means a is less than or equal to some of the other two, and then same thing with the other variable. So like if I want to kind of take the maybe first equation, because I kind of use these three to get these ones, right? Let's use the first one now. So the x plus y plus z is larger than or equal to 2. Okay, and I do know like x was the 2 minus a, so I can plug that into this equation, and then y would be like 2 minus b, and then z is 2 minus c is larger than or equal to 2. So the one of these 2's will cancel, so you got 4 is larger than or equal to a plus b plus c. Okay, this is promising because we now know the sum of these to be at most 4, and then a, b, c are non-negative, and then we can use the starting bars to get our solution. So imagine like the sum of these a, b, c is 0 or 1 or 2 or 3 or 4. So by using starting bars, we can just say we have like 3 stars. I will make that, 3 is like 0 stars. Like imagine this is a plus b plus c is equal to 0, 1, 2, and 3, and 4. If this is like you have 0 star and then 3 bars, so you can say 0 plus 3 minus 1, and then choose 3, choose 1. That's the first one. And then if you do the second one for 1, and then that gives us 1 plus 3 minus 1, 3, choose 1. And then you can do this the other one. The last one will be 4 plus 3 minus 1, choose 3 minus 1. And if you don't know the starting bars, this might be a bit challenging to understand, but I'm going to maybe add some stuff in the description so you can take a look at more details how we get these. But the good news is like you don't have to do this separate. Even though we have only 5 of them, we can do easily. That's going to be 2, choose 2. And then the next one will be 3, choose 2. And if you keep doing this, the last one will be 7 minus 1, 6, choose 2. So you may just add these together, but the good news is, the bottom numbers are 2 and then the top numbers are increasing by 2. We have a combinatorial identity for this one, even if you may not know the name as well. So that should be actually 7, choose 3, which is 35. Again, if you don't know that, you can just separately add them. So that will be easier to do so as well. But this is the total number of cases. Like that does include all the ABCs, right? So, but we want some cases where, this is the satisfied case, but this does include everything where a is actually less than b plus c, or the other way around. So let me take that. So like if a, so I should probably take some of these out of the way. Let me not take this one. So like if I want to take these out of the way, so we can kind of see what's going to happen. So like what I'm going to do now, like imagine the case a is less than or equal to b plus c. This inside of this one, right? But there is a case where a is larger than b plus c, right? So then what are those cases? Because this is the case that we don't want to take in this 35. So in this case, like if I choose like b plus c, the case 1 b plus c is equal to 0, then a has to be, the sum of the other one has to be like all the way to the 4. So you can have like a is like 1, and then b and c 0, 0. So you got 0, 0. So that's the first case. And then if the b plus c is 0, then you can have 2, 0, 0 as well, or 3, 0, 0, because the sum of the ABC has to be at most 4, so you can do this all the way 4, 0, 0. So we have 4 cases. But if b plus c is equal to 1, then you do get a is going to be more than that, so which means it should be like 2, and then b plus c is 0, so you can have 0, 1, 1, 0. So, and then you can do this like 2, 0, 1 like as well. So I will say 2, 0, 1. Or you can have, let's say, the 3 for like a, so you should get 1, 0, and then 3, 0, 1. Okay, and then there is nothing really else we can do because these are the only 4 of these. So we have 4 cases that is not valid. There is 4 cases right here that's not valid either. So that means 8 cases is not valid if you take the a is like larger than b plus c. And then if you take the same thing with b version, like b is larger than like a plus c, you got 8 more disqualification as well. And same thing with 8 for the last case. So you should have 35 minus 3 times 8, which is actually 11. So this is one way of doing this problem. I think we can do the casework because the choices are not too like many. So which is like in terms of the size. So you can just maybe list them carefully. So you can maybe get 11 easily better than this approach. But I think I just did this way anyway. Okay, so that was number 9. Okay, so here's the number 10. So f of n is given n cubed minus 5n squared plus 2n plus 8, and then g of n is given similar to. And what is the sum of the integer values of the fraction is also integer. Okay, there is a like rational expression going on, and we like this to be integer. So, but let's start with maybe try factoring the numerator and denominator to see if this is like factorable. Because if the ratio of two things is integer, that means denominator should have should be like numerator should be divisible by denominator. So maybe we should have some common factors to cancel. So one thing we can do, we have the constant terms like 8 and 12. Maybe we can use the rational root theorem to get the factors, and that would be like I will start with 1 because 1 is the divisor of 8 and 12, so it's easier to check. That will give us like 1 minus 5 plus 2 and plus 8. So it is not equal to 0, so that means 1 is not a root. So let's try -1. So you should get -1. Q is -1. So you got 1 times this -5. So you just plug -1. So you get -2 and plus 8. So it is actually 0, which is good one. So let's try this one as well. So that will give us -1 minus 6 minus 5 plus 12. And that is actually is equal to 0. So which means -1 is a solution. It's a root of both expressions. So we can just say the f of n is equal to n minus 1, actually n plus 1, times something. And then similarly, g of n is equal to n plus 1 times something. So since this is a cubic, we can just use the standard division. So let's do that. So I'm going to take the -1. And the coefficient is like 1, -5, like 2, 8. So I'm going to drag this down. So this time this will be -1. So when you combine, you got -6. -1 times 6 will -6 will be 6. So that should be add up to 8. And that will be -8. So that is 0 as expected. So this is going to be my quotient. So which is going to be x squared, -6x, n squared, -6x, 6n plus 8. And I can use the same logic with the other ones. So I'm going to take the -1. And the coefficient are 1, -6, 5, and 12. So that should give us like 1 times 1 is -1. When you combine these, you got -7. So you got 7. So that's 12 and -12 and 0 as expected. So the then coefficient will give us the quadratic expression. So you got n squared minus 7n plus 12. So we just use this in the division basically. And that will give us n plus 1. And then this is also factorable as n minus 2, n minus 4. And that will give us n plus 1 times n minus 3 and n minus 4, because that's also easier to factor. So let's get this out of the way. So like when you write the f of n over g of n, so we got n plus 1, n minus 2, n minus 4 over n plus 1, n minus 3, and n minus 4. So the good news, these guys will cancel. So you got n minus 2 over n minus 3. So we want this to be integer. So we can maybe get this exactly in the numerator. So you should get right n minus 3 plus 1 over n minus 3. And that will give us like n minus 3 over n minus 3 plus 1 over n minus 3. So that's just 1 plus this expression. So the 1 plus 1 over n minus 3. So we want this result to be integer. So to get this integer, this fraction should be constant. So 1 should be divisible by the n minus 3. So the n minus 3 could be -1 or +1. In that case, that would be integer. Then you got 3, add 3 to both sides. So you get 2 and 4. So we got these two. But if you combine these, you actually end up getting 6, which is actually not the correct answer, because the 4 is actually the number that we cannot plug into, because this fraction is undefined at 4. So we really cannot have 4 for our n. So the only value actually works is 2. So that was a bit tricky, to be honest, for number 10. So that was choice A. Okay, so let's do the next question. So here's the number 11. So on Monday, 6 students went to tutoring center at the same time, and each one was randomly assigned to one of the 6 tutors on duty. On Tuesday, the same 6 students show up, and the same 6 tutors were on duty, and students were again randomly assigned to the tutor. And what is the probability that exactly 2 students met with the same tutor on both days? So this is actually the example of the arrangement of the case. So we do want to get exactly 2 students out of 6 will be the same. So which means we are actually looking for D4. So again, if you don't know about the arrangement, so you may take a look at the the note I'm gonna attach. So it's basically, the arrangement is basically a combination, a permutation of a set of elements in which no elements remain in its original position. In this case, we are going to have 4 of these people will kind of swap. So that's why we are looking for the D4. But the question is, we have 6 people, and then there is like 2 ways to decide. I mean, 2 ways to, like 6 choose 2 ways to decide what 2 people will have actually not changed. So which is 15 ways to do so, right? And then we are looking for the D4. So the D4 is equal to, we kind of start with a permutation, like some expression. So it is going to be 4 factorial. Maybe I should like remind the general before I actually apply this. So when you have like the n, and then I will just use the factorial on this side, which is one way of showing the derangement. So this is equal to n factorial and minus n factorial over 1 plus n factorial over 2 factorial, and then minus n factorial over 3 factorial. And it will continue all the way -1 to the n power times 1 over n factorial. Okay, so this is just general way of saying this one. So we want to find the D4, so we just start with them. So that should give us 4 factorial over 1 plus 4 factorial over 2 factorial minus, you will get the 4 factorial over 3 factorial, and then plus 4 factorial over 4 factorial. So the first one is like 24, and then minus 24. 24 over 2 is 12, and then 24 over 6 is like 4, and then plus 1. These will cancel, so you get, so the 8 plus 1 is 9. So which means there's 8 ways to do so. Since we have like 15 ways to determine what 2 individual will actually be the fixed, not changing their days. So that means it's either on either day. So you got 15 ways to determine that, and then 9 ways to finish the remaining part. So this is our desired kind of probability or number of ways to do so. And then divide this by the number of ways to arrange when you have no restriction, which is just 6 factorial. And if I clean this, you will get 3 times 5 times 9 over 6 times 5 for 3, 2. So I can cancel 3 and 5. So, and then you got 9, so I can divide by 3, so that should be 2. And then that will be 2 times 4 times 2, which is 16, 3 over 16, which is choice B. Yeah, that was a kind of quite interesting problem, but if you've never seen the arrangement, then this might be a bit challenging. I will kind of challenge you to try this question if you can come up with another solution without using this at all. Okay, so that was number 11. Okay, so here's number 12. So the figure below shows an equilibrium triangle, a rhombus with 60-degree angle, and a regular hexagon, each of them containing some mutually tangent congruent disk, which is like circles, and then T, R, H, respectively. So the first one was the triangle, which means this has to be T, and then the next is like R, and this is H. Okay, and the ratio of each case of the total area of the disk to the area of the enclosing polygon. So area of these 3 circles to area of the triangle, or 2 circles to area of the rhombus, or the sum of these areas of the circles to the area of the regular hexagon is what we are interested. And we want to combine, like relate those. Like one thing is like I can do, since this is like number 12, I wouldn't probably do too much work, especially in terms of competing stuff. So like if I connect these two, or if I even take this midpoint and connect with each center, each vertex of the hexagon, so we'll actually see something nice going on. So like if I connect this way and that way and this way and that and this way, so like each one of these, like let me take this separately. So when you think about this one, this region, this is actually the same as the other one. So which means if I know the area of this circle divided by area of this triangle, that's going to be entire figure as well, because you have identical the triangles as well as these circles inside. So which means whatever we got right here is the same for H. And the same idea with this entire figure. So if you take this triangle and then compare the circle with this triangle, that will actually be the same as the entire figure. But it doesn't look like with the same case with T. So meaning that like the R and H will actually have the same ratios. Why? Because we have equilibrium triangle and then there's a circle inside. So that's why there's no really numbers argument. So we just need to make a deduction from that idea. So that's why the area of this triangle, when you divide by this circle area, that ratio, or the other way around, like circles area divided by triangle, is the same in this case with that one. So which means R and H are equal. So we have RT is equal to each other. So this is no good. So this is maybe, and then RH is good. And then this is no good. And then this is no good as well. So we have only 2 options left. So C or A. So the thing is, if you want to have the same logic with this one, I would love to kind of see this circle is actually surrounded by 3 segments, so we can make equilibrium triangle. But that means the third segment should be like this way. But when you have such a thing, there is a region right here is actually gonna be like, it has to be white in this region, but it doesn't look like it's white, which means if I want to do the same thing with the top one, so that doesn't really look like the case, but let's say I'm going to do it this way, so that will be quite triangle looking stuff. And then same idea with this one. So there is some region that is actually like outside of the region. So which is why in the first diagram we actually have more shaded region compared to the unshaded region. So which means the T has a bit larger value in terms of the ratio of the shaded to entire region. So it looks like our T has to be larger than the other two, which is going to be our choice C. So like if you don't really buy this, you can actually go ahead and do manual work, which is kind of possible as well. So I'm not going to finish the rest, but I'm going to let you at least see how we can do. And then you can make like, let's say the radius is like 1, and then that will be 1 and 1. And then you can make this guy as that will be a 36 and 80 triangle. So you got √3, and then that should be 2 because 1 plus 1, and then there is another √3. So you can find the area of the equality triangle. So that's 2 plus 2 √3, and then compare with the sum of those three circles, and then that ratio, and then you can do the same thing with this one. Even though I don't really know the numbers, I can find the ratio. When I got two different ratios, I can actually compare those ones. If I do so, you will see that T is going to be still larger than R as well by numbers. So you can just check that if you don't buy this approach at least. Okay, that is choice C. Okay, so that was number 12. And number 13, the altitude to the hypotenuse of a 36 and 80 triangle, right triangle, is divided into two segments of length x lesser than y by the median to the shortest side of the triangle. What is the ratio of x over x plus y? So let's make a diagram. I'm going to make it a bit larger so we can actually maybe see things slightly easier. And that's usually a recommendation during the test as well. So we do have a right angle, and then we drop the altitude to hypotenuse. And also there will be a median to the shortest side of the triangle. So if this is the 30 degrees, that means shortest side will be that side. So that means this is going to be my median. Okay, and let's label this is 90. This is 90 and 60, or 30 and 60. And I will just label this as like 1 and 1 because at the end we are looking for a ratio. And then this is 30, 60, 90 triangle, so hypotenuse is 2, so that length should be just half of that, which is 1. And then this is 2 units. This is 30 degrees. That means hypotenuse of the largest one should be 4, so that should be 3 and 1. And if you do know the geometric mean, you can actually say square of 2, that's 4, is equal to 1 times entire hypotenuse, so you can get that for immediately. And then you can even get this altitude in this 30, 60, 90 triangle, which will be just √3, right? So, but we want to know the ratio of this to this. Let me label these actually. I will call, let's say this is A, B, and C, and I'm going to say this is H, and let's say this is P. Okay, and since this is kind of median, I'm going to use M. And we want to find the ratio of B, P, and PH, so we can kind of find the ratio of those two. So one thing we can do, like we can try to use the coordinates, right? So like this is 2 units, so that should be 2 √3. So I can say this is going to be 2 √3, comma 0, and then that will give us 0, comma 2 for the point A, and then that will give us the 0, comma 1 for the point M. So you know there is a line right here. Maybe I can write the equation of this line, and then if I can write the equation of this line as well, so I can find the intersection easily, which is one way to do so. And the second thing we can try using, we can drop the altitude from H to B, C, so we can get the similar triangle to this one because we know the 3-to-1 ratio. That might be useful. So I'm going to use that for now. So even though I'm not going to, maybe I should, I can drop the altitude like this. So that altitude, which is going to be my y coordinate, I'm going to call that's y, over the 2 is equal to the 3 divided by 4. So with that, we can just get the y as like 3/2. So, and then if I want to say this is like 3/2, maybe I can find the exponents easily. So one way we can do, like, actually I should maybe show it, since I don't want to make too messy a diagram. If I want to kind of do this one, so the y coordinate is 3/2, which is kind of reasonable because this is 1 to, actually that's the y value, so 1 to 4, so that means 3 to 4, and then that should be 3/4 of this height, so that's going to be y-intercept. And then if I want to find the x-intercept, so 1 to 3, so then if we divide entire BC is like 2 √3 to 4 pieces, so you got like 2 √3/2, which is going to be √3/2, which is going to be our x coordinates as well. So you can use just the ratio of the triangles, or you can just use that 3690 as well, because this is 60 and then this is 30, as soon as you know the y value, which is 3/2. So right now this one, and that's opposite to 60 degrees, so you can divide this by √3 to get the other length, which is going to be √3/2 as well. Okay, so either way we got the coordinates. So now we can maybe find the equation of this line. So I'm going to solve MC. So for MC, right, so the slope is the 1 divided by 2 √3, but that is just the negative because it goes downward. So you got negative x over 2 √3, right? So I don't want to miss anything. So this is y and this is x. So that will be slope, and then the y-intercept would be just 1. So that's for MC. And then if I know the BH, maybe I can solve that system. So that would be, I guess, fine. And then this is BH. And now maybe we can use that point and this point. Like we didn't really need to find this one at some point. So you can find the, let's say, the slope of these two, A and C, and then use that to get the slope of BH because they're perpendicular. As soon as you know the slope, and then there's like 0, 0, so you can try find the equation. But anyway, so we got that point right now. So then I can use 0, 0 and this point to write the equation. So BH will be like the y equals, the slope will be rise over run. So you can use this, or you can just say tangent 60, which is root 3 over 1. That is just root 3. So root 3x, and then equals the origin. That is just the equation. So if I want to solve this system together, so make them equal to each other. So you got x root 3 is equal to this one. So I can add this to both sides. So you get x root 3 over 6. So I just simplify this one, and that's equal to 1. And that will give us 7x root 3 over 6 is equal to 1. So the x should be 6 over 7 root 3. I'm not going to simplify for now if I don't need to, so I'm going to leave it as it is for now. But what is the x? X is the intersection of those two lines, which is the x coordinates right here. So the p, right? So the point P has 6 over 7 root 3. And then you may find the y, I mean, this is x coordinates. You may find the y coordinates if you want to, which is like what we actually can use, but I can use x-intercept as well. So like we got this distance as 6 over 7 root 3, right? And then if I compare that one with this distance, which we know that's root 3 over 2, that will be equal to BP to BH. So I'm going to write that. So the BP over BH is equal to this distance, which is like 6 over 7 root 3 over BH is the divided by this entire distance was root 3 over 2. And if I simplify this one, so you should get like 6 over 7 root 3 times 2 over root 3. And then these will be multiplied to get 3, so you can cancel that by that. So that should be 2 times 2, which is like 4 over 7. So, but let's not answer the question immediately. So 4 over 7 is like BP divided by BH, which means if I call this is like 4K, so that should be like 3K. So, and then we are looking for the x is the smallest one, which is 3K. So x is the numerator, that's 3, divided by some of these, which is 7. So that is choice A. So like if they actually give us the choice as like 4 over 7, some people may probably choose that one, even though we are looking for some ratio that is lesser than 1 because x is the smaller one, right? So that like another maybe trap, but I think that was okay. That was good to have no choice like 4 over 7. So that is choice A.